Hello. Welcome back. This is Leetcode 524, longest word in the dictionary through deleting. So here you're given a string S and a string array dictionary. I want you to return the longest string in the dictionary that can be formed by deleting some of the given characters. If there's more than one possible result, return the longest word with the smallest lexicographical order. If there's no possible result, return an empty string. So basically, one thing that this question doesn't specify is that you want words that are subsequences. Basically, we are looking for the word that is a subsequence of s and is the longest, basically, right? Or is having the length as the same as the longest, except it's the lexicographically smallest one. So for example, we have apple here, right? Apple is a subsequence here. The question doesn't necessarily specify, right? So you would think that maybe you could swap it around, but it's not necessarily the case. It has to be a subsequence. Okay, so how do we approach this question? Well, easily, one thing we can do is we can take every word in our dictionary and check if it is a subsequence of this. If it is, right, then awesome. If it's not, then we do not use it, basically, right? So the ones that are subsequences, we find the one with the biggest, the best length, or the one which is what the lexicographically least one. So um how let's just get into the coding basically, right? So I want to have a string and I'll call it a string. I'll call it max string. Right, this is what we are going to return in the end. Right now we just have to have our for loops. So we're going to loop through every single word in what our dictionary, right? So word in dictionary. And basically for each word, I want to keep an index. I'll call it I, right? I will iterate through the word. And then I want a character array. Basically, I'll call it a word array, which is going to be our word in what character form, right? So, and then the same for the S also, which we will be doing the comparison with, right? I'll call it SR, which is going to be what, S2 character array, basically, right? Okay, so I have indices, I have I, and I want to add another index, I'll have J, right? So I just have two distinct indices going through these words. So basically, how do I know if the word, for example, Ali or Al, is a substring of what dictionary? Well, basically, you compare the words, right? If I find an A, or I do find an A beginning, right, then I move my index for Ali to the next one. Right? I'm now looking for an L, and then I go through this whole thing, then I find an L. Okay, fine. And then I find an E, right? I move this index to E, and then I also find an E eventually. So I know that Al E is a subsequence of what S, which is this word. Okay. So and the same I'll do the same for Apple and stuff like that. So excuse me. Um I have a while loop, and basically my I is going to go through word, right? So while I is less than word dot length, and basically also our J is less than what S dot length, right? Now, if the word R at I is if that is the same as what SER at J, then I can move my I, right? I can move my I through the current word I have. Guys, go to the next index and look if we find a corresponding one, basically. And all the time, I'll be moving my J, basically, right? I'll be moving my J pointer, and that's that. Now, how do I check if we actually reach the end of the word? For example, Ali. I check by saying that um, number one, that the length of the word we are having, right? So the word dot length should be the same as my index, right? My index I. Sorry. So if the word dot length is equal to I, then I know we have something good, right? I've been able to reach the end, and then I want to check if our max string dot length is less than or equal to, sorry, it's less than or equal to our current word, right? So if our word has a greater length or it's equal to its length, then I want to, make a computation based on that, right? To change max length, max strength from there. So this is in the initial one. Are we at the end of word? Yes, we are. And it's our max string less than or equal to our word, right? Is our word longer than or equal to max string? Yes, it is. Um, so that's the only case in which this executes. So if this executes, right, then I want to check two things right now. I want to check if by default, right, if the word's length, if it's greater than our max length, our max string to length, then fine, I can just change our max string to our word, right? Or I want to check based on a previous connection. If it is not less than it, then it means that they are both of equal length, right? So if they are equal length, then I want to do word dot compare to what max string, and basically this is going to give us a value, and if it is less than 0, it means that basically that word is lexicographically smaller than what max string. Right. So this is the basically the cases that we want, and in each case we want to set max string to our word currently, and then that should be it. Once our while loop is done, our for loop is done terminating, we want to return max string. Okay. And I have two errors. Oh no, so we have returning empty string, meaning it's not making a change. Do I have these swapped? I think I do. Oh, am I? If well, hold on. If the max string, so we want word dot length to be greater, right? Sorry, if the word dot length is greater than a max string, then that should execute. Yeah, cool. So basically, I was saying that I want the word dot length to be greater than our max string, right? That if it's greater than our current max, then we can set our max to that current word, passing the first two test cases. Let's see, and it passes 74%. So basically, the question is about subsequences, and if it is a subsequence, right, we check if it's the lexicographically the lexicographically smallest one, or it's longer than it, right? So if it's longer than our max, then we set it. What's the runtime? Well, basically, if we have k elements in our dictionary, right, we are going to iterate through each single word, right? So we're going to use k, and let's say the word with the longest length has n elements inside. So in the worst case, we are going to have O of n times k being our runtime complexity. Guys, I hope you guys enjoyed this. I'll see you guys on the next one. Peace.